Hello students, in the last video I said I would do a few example problems, so a few example problems I shall do. Now, I'm going to do 3 expansion problems, 3 condensing problems, and 3 solving problems. And these are problems that I pulled just kind of randomly, and I'm going to work them for the first time with you right now. So you can kind of go through some of my process, and I hope that it helps you identify your process as well. So if we encounter any problems, we can kind of figure it out together. Let's do this. So when it says to expand, you'll notice that all 3 of these problems are given as a single logarithm. Expansion involves taking out as much out of that logarithm as you can. Like, you're still going to want to simplify, which it looks like at least one of these problems is going to simplify, but we're really just trying to break up this log into as many pieces as possible, and we're going to use our log properties that we learned in the last videos to do that. Okay, so this one is actually just a really simple one. What you have inside of this logarithm is a product. So we're going to use our product property, right? The base is going to stay the same, and when we have 2 numbers that are multiplied together inside of a logarithm, we can break it up into a logarithm plus another logarithm with those factors. Okay, so this one, we're going to have log base 7. And then what's our first factor? Well, our first factor is a plus, because it's multiplication, we're going to use a plus sign. It's part of our rules. Plus log base 7, keep that thing the same. B is our second factor. And it looks like this is not gonna break up any more than that. I can't pull this A apart because I don't know what this A is. Same deal with the B. So really that's all there is to it. We just applied our product rule to this one. So let's see if this has anything to offer for us. Alright, so I can tell that we're going to be using our product property again because it's 7 times x squared. And this squared, that means that this is a power, so we're going to use our power property too. The question is, which do we want to use first? Well, and we have to work from the outside in, basically. We can't use the power property first because this squared, it doesn't apply to the 7. This is x squared. This is not 7x squared. If there were parentheses, we'd have to get rid of that power first, but there's no parentheses, so we actually need to sort of do the opposite of our order of operations. We need to break up this multiplication first, so let's do that. Okay, so our base is going to stay the same. It's 7. And actually, all the problems I grabbed have a base of 7. I don't know why. Don't ask me. But our first factor is going to be 7. And they're being multiplied, so that's an addition problem. And then we got a log base 7. Again, that's supposed to be a 7. And x squared, right? So that's our second factor. But we are not done yet because this requires us to get rid of this power. We can break that up a little bit more. We're gonna take everything that's inside the log outside of the log if possible. Okay? So ultimately we're gonna have log 7, and those of you who are pretty sharp probably realize that this can simplify, but we'll get to that in a minute. This 2, if we apply our power property, this power is going to go on the outside of the logarithm. So 2 log x. Okay, so at first glance, it's like, okay, well, I can't do anything anymore. I can't like pull this out or pull that out. These factors are prime, and there's no more powers or anything like that. So at first glance, you're saying, oh, well, I'm done. But some of you noticed that we have the base 7 and the number 7 in this logarithm, which can be simplified, right? This is asking us 7 to what power equals 7. So when the base and the number are the same, it's going to be 1, right? Because 7 to the first power, 7 to the 1th power, so to speak, is 7. So that would become 1 plus 2 log, oh, I forgot my base 7 up there. Base 7x. Yeah, can't forget your bases. Almost did, but this is our answer because I can't break that up anymore. All right, so let's look at this guy. We got log base 7x squared. So we're gonna have to do the same thing over here. It just looks like we're gonna have to use a power rule one more time than we did over here. It's still gonna use a product rule, so I want to break this up. Okay, so we're gonna break it up. We're gonna have log base 7 of x squared because we're multiplying. We're gonna add log base 7 y cubed, okay? And now these exponents are going to move out in front. So that 2 is going to come out in front on this side, log, well, not this side, this is an expression, not an equation, but base 7 x, now we don't have a power here. This 3 is going to come to the outside of this log, 3 log base 7y, and there's nothing more than we can do. There's no more properties that we can apply. So this right here is our answer. There's our answer. And there's our answer. So I hope that kind of shows you what I'm talking about when I say expand, whenever I'm expanding some of these guys. So let's move on to condensing and see what that looks like. All right, so these, we have multiple logs. We're really, ultimately, what we're trying to do is we're trying to pull them all into the same logarithm. That's what we're trying to do when we condense something, okay? And we simplify if possible. So we are adding 2 logarithms, which means that we are going to have to use our product property. But we also have this 8 out in front, this coefficient, so to speak, and this coefficient is going to be applied using our power property in order to get it inside the logarithm. So let's just go ahead and do that. First thing, we'll just go ahead and rewrite this. Don't want to get ahead of ourselves. So log base 7d plus, okay, so we're going to pull this 8 into the logarithm. Log base 7c to the 8th power. So that 8 is going to go in as a power. That's a power property. Okay, now we're ready to get a product here. We're going to pull both of these together using the product property, log base 7 of d times c to the 8th. And unless I'm mistaken, we're all in the same logarithm, so that's it. That's the condensed form. So there's one of our answers. Let's look at this guy. Aha, this is the first time we have a subtraction sign, so this is the first time in all these problems we're going to use a quotient, right? We also have a coefficient, so we need to use the power property, right? Let's go ahead and use that power property first. So rewrite this as log 7b minus log, I'll get that exponent inside the log, so b squared, that 2 is going to become a squared in here. Okay, now I'm ready to use the quotient, alright? So log base 7, the 7 is going to stay the same. Then, what do I have? I have b divided by b squared, because the order matters. The first one's going to be on the numerator, the second one's going to be on the denominator. So I have log base 7 b over b squared. Now, you might be tempted to stop here because you just have one logarithm, but this thing simplifies, right? That we have a common factor on the top and the bottom. Okay? So we can simplify this, and you should get 1 over b, because if we take a b out of each of these, b divided by b is 1, and b squared divided by b is b. Alright, so why don't you go ahead and pause the video for a little bit and see if you can solve that third one now that we solved the second one. See if you can solve this third one all by yourself, and I'll be back with you in just a couple seconds. Alright, I hope you pause it. I mean, there's no way to tell whether you did or not from my end, but, you know, it's good for your practice. So let's take a look at this. Log 7, so we're adding, we're using product rule again. We have one coefficient, so we're going to use the power property. So you guys should be pretty well acquainted with this now. Let's just go ahead and show our steps. It's supposed to be an A. Plus log 7b to the third, because the 3 moves inside. Let's put these guys together. Log 7ab to the third. And we are done with condensing. Alright. Let's look at some of the more challenging ones. We're going to solve and have to do these one at a time. Alright. Now this, solving, is when you are trying to find the unknown variable, which our unknown variable in this case happens to be this in here. So we're going to use our power properties to kind of simplify this, make this easier to work with. Okay, so let's go ahead and start. 2 is going to go on the inside here. We'll have log 7 in squared, okay. No coefficients out here, but we can combine these using the product. I don't know if I actually want to do that, because 27 times 3, that seems like it's larger than I want to deal with. Let's see if I can do it. No. Nah, fine. I got to do it that way. All right, so 27 times 3. Let's do it. 3 times 7 is 21. Carry the 2. 3 times 2 is 6. Plus 2 is 8. So 81. And yes, I always encourage my students not to use calculators. It just kind of helps with the math process. But those guys are going to go together using the product rule. And so we have this. Now, this is an interesting situation. Log 7 n squared, log 7, 81. When the logarithms have the same base, you can actually ignore them or cancel them out, only if they have the same base, mind you. For the same reason why you can cancel out the bases on exponent problems. One of my coworkers likes to call it bye-bye log problem. So bye-bye logs. And all we're left with is n squared equals 81. And we just take the square root of both sides, right? Square root of n squared, square root of 81. So we have 9. Now, in real life, we have plus or minus 9. I think that we can get away with just leaving it as a positive 9 for our normal classes. We don't need to worry about extraneous solutions. So, as far as I'm concerned, your teacher may tell you differently, but I'm okay with this. N equals 9. Right? All right. So let's look at the next problem. Fractions, your favorite. Okay, let's go. This side is already as kind of simple as we can get it, but we can do something to this side, so let's go ahead and do that. We've got a coefficient equals log 7, 8 to the 2/3 power. I pulled this 2/3 from the outside coefficient to the inside as an exponent. Okay, we've got another bye-bye logs problem. We can kind of ignore these bases and just set these guys equal to each other. N equals 8 to the 2/3. Okay, so what does this fractional exponent means? It means that we are going to take the cubed root of 8 squared. So n equals, we just rewrite this as the cubed root of 8 squared. And 8 squared is 64. So the cubed root of 64. And you should have this memorized. The cubed root of 64 is equal to 4. So n in this case equals 4. Okay, so yeah, that one's a little bit more challenging, but it's not too challenging as long as you remember what to do with that, right? Okay, so let's do this last one here and see what we got. Okay, we got 2 logs on this side and just a number over here. It looks like we're going to be using our quotient rule, so let's do it. We're subtracting, so we use the quotient rule. Log 7, it's going to be this as our numerator, so n plus 10. Over that is our denominator, n minus 1, equals 2. You know what, actually, I think that there might be a better way to do this. Give me a moment. No, there's not really a better way to do this. We're just going to have to take this into its exponential form, which, hey, that's okay. I mean, that's what we're working with logs with anyway. So 7 is going to be our base. Let's put this in exponential form here. 7 is our base. Our exponent is 2. So 7 squared equals our number, n plus 10 over n minus 1. All right. So 7 squared is 49. That's good. Equals n plus 10, n minus 1. Hope this doesn't get too bunched up. All right, so we can multiply both sides by n minus 1. So 49 n minus 1. And of course, if we multiply this side by n minus 1, that'll just get rid of what's on bottom. That was the point. Okay, so I'm gonna move up here now. So 49 is going to distribute into the parentheses. We'll have 49 n, 49 times n, 49 times negative 1 minus 49, okay, equals n plus 10. This is a doozy of a problem. So we'll try and get all of our variables on one side, and we'll try to get all of our constants on one side. So let's add 49 to both sides. Let's say add 49 here. We'll add 49 here. Okay, we'll get 49 n equals n plus 59. Almost done. Okay, we'll subtract n from both sides. Subtract n from both sides. This is 1 n, and we have 49 of them, so we're going to wind up with 48 n's on this side equals 59 on that side, because the n's will cancel out, right? And then we'll divide both sides by 48. Alright, so that doesn't simplify. That is not a reducible fraction, so it's messy, but it's the truth. 48. Sometimes you get some weird problems, but there it is. There's the answer. So I hope this helps you with your homework, guys. Have a nice one. I'll see you in the next video.